Okay guys, so in this unit we're going to be talking about the applications of the stuff that we did in the last unit. It's my third time doing this video, so I'm kind of cranky, and for that reason I'm just kind of getting cut to the chase. So in the last unit we talked a little near the end of the unit about definite integrals and how we could use that to find the area underneath lines to the x-axis. So this unit we're going to take that knowledge, we're going to expand that a little bit further, and we're not just going to be talking about area, but we're going to be talking about things like volume and talking about all these different things that you could do with this knowledge. But to start off, I'm just going to teach you some little transformations that you're going to need to know how to do for this unit. So for example, I have right here this line 4 minus x squared, which I graphed right here, and as we know from being good algebra students, this is 4, this is 2, and this is negative 2. If you wanted to know what the area underneath this curve was to the x-axis, aka if you want to know what that part was, then you would just do an integral from negative 2 to 2 of 4 minus x squared dx. However, and this is helpful if you want to know this area, and you need to definitely know how to do this. But what if you want to know the area of this exact same line of the 4 minus x squared, but instead of doing it to the x-axis, what if we wanted to do it and find the area of this to y equals 2? So it'll be like this. You want to know what that area was. Well, there's a couple things you could do, but to just make this plan simple, there's actually a very easy way of thinking about this. What you're doing here is you're actually shifting the graph up. And what I mean by that is you actually have a different graph. It's not 4 minus x squared, it's another graph that looks like this. That looks exactly the same, sorry. You have another graph that looks like this, and you find this area. And instead of this height being 4, now this height is 2. So what we have here is we have the 4 minus x squared graph, but it's moved down 2. And for that reason, the new graph is 2 minus x squared. Do you understand how these areas are the same? Well, if so, then you can just think of it like this, that to do this, if you want to know from here, all you have to do is do the 4 minus x squared, but then you have to subtract the 2 in the y direction that you're losing, so you get minus 2 dx. Alright, there's one more thing that's going to have to change for you to be able to do this, and that would be the bounds. It is no longer going to be negative 2 to 2, because if you look and you drew these down, you would notice that this isn't at negative 2. It's at a different point. How would you find out what that point is? That's where the algebra would come in, but basically, you wanted to, if this is at 2, y equals 2, then just plug into the equation. Y equals 2 equals 4 minus x squared equals 4 minus 2, which is 2, x equals plus or minus square root of 2, and so therefore, if this point is at x equals negative root 2, and this point is at x equals positive root 2, there you go. That right there is the integral that will give you that area. Now knowing that knowledge, we can use it to do a little more complicated things. Let's say I actually have a practice problem right here already prepared for us to do, and I don't have a calculator in front of me, so I'm going to basically be doing this. You can type in your calculator if you want to get the exact answers, which I will put up. But let's say you want to know the area bounded by these two lines. Y equals, oh, also, did you notice there's no glare in this video? It's because I have another lamp over here that I'm using, but yeah, anyway. So we have y equals x cubed minus 9x, and y equals x squared minus 2x. This is a little different. Before, what we did was we had something like this, but then we had like just y equals 2, basically. We just wanted to find the bounds between that. What we did was we took the original function, which was 4 minus x squared, and we just subtracted it by this. Basically taking the bigger one and subtracting it by the littler one to get the one that's in the middle, and then we change the bounds. That's kind of what we're going to do in this one, except it's a little more complicated, and you'll see why. So if we graph this, you get, well, this equals x times x squared minus 9. So it's going to be a cubic equation. This is going to be 3 and negative 3, and it's going to look something like that. God, you can't even see that. I've been doing so many videos for this that like my marker's starting to run out. And then x squared minus 2x is the same thing as x times x minus 2. And so right here there should be a thing, and it should look kind of like this. So these are your two lines. The area in between is this right here and this right here. And the question is asking you to find that area. So we're going to do what we did before. Now, it's going to be a little more complicated because the area, this equation is the upper equation, similar to the 4 minus x squared one that we had before, and this one's the under equation, so you would just do an integral with this one subtracted by this one. We'll talk about the bounds in a second. But it switches over here. Now this equation is actually the upper equation, while this one's the under equation, so you need to reflect that in your integral. And I'm looking for a marker of a different color to use. I can't exactly find, so I'm just going to use this blue one. You might have trouble seeing this, I don't think you will, but basically what we're going to do is we're going to just do two separate integrals. We're going to do integral, once again, I'm leaving the bounds off right now, and we're going to do this top one right here, which is x cubed minus 9x, and subtract this under one, so minus x squared minus 2x would be plus 2x dx, which is the same thing as x cubed minus 7x, or I should say minus x squared minus 7x dx if you simplify it. Now what we have to do is get the bounds. The bounds would be this point right here and this point right here before it switches the lines, and then we'll do a different integral for the other half. So to find that, we have to find out where these points intersect. And to do that, you're going to have to set these equations equal to each other and find out where the intersection is between the 2 points, kind of similar to a system of equations that you would do in the past. So it would be like x, I'm sorry, I'm doing this, I'll move in a second. X squared minus 9 equals x minus 2. Similar to that, the x would cancel out. X squared minus x minus 7 equals 0. And long story short, then you can do that and you can factor it, but you would have to use a calculator or use like negative b plus or minus square root of b squared minus 4ac over 2a to find out what that is. So basically, I'm just going to call this point A because I don't want to have to find this right now, but you would have to in a real equation or a real problem. This is B. However, we know because they both intersect as 0, 0, this is just 0, 0, so I don't even need to get that variable. Then this point right here, which we're going to need later, we're going to call that B. So therefore, this from A to 0 is that. Then we're going to add the second one, and the second one's going to go from 0 to B, but as you notice, the equations switched to which one was on top, so now it's going to be x squared minus 2x minus x cubed plus 9x. And yeah, that's how you would find the area in between two lines, is you take the top, you do an integral of where they intersect and from those 2 points, and then subtract the biggest one minus the smaller one.